Hello, I am Shubhakar Nayak, lecturer in Polymer Technology, Karnataka Government Polytechnic, Mangalore. On behalf of Department of Collegiate and Technical Education, I am going to present PPT on fundamentals of extrusion and extrusion process. This is the session 2 of Unit 2. Program is Polymer Technology, course Plastic Processing Technology for third semester. Course outcome. The student shall understand the basic knowledge of extrusion process. Let us have a quick recap of our previous session, session number 1. We have come across fundamentals of extrusion process, very basics, that is what is called single screw extruder and twin screw extruder, and how the flow takes place, drag flow, pressure flow, etc. in our previous session. In today's session, we are going to discuss about the various topics like extrusion of pipes, profile extrusion, extrusion line for cable industry, film extrusion, that is different types of film extrusion, blow film, flat film, sheet film extrusion, etc. Now, to begin with, let us discuss with pipe extrusion. Pipe are very important type of products nowadays. For different purposes, we make use different pipes. How the plastic pipes are manufactured? Basically, there are different types of materials available like PVC, HDPE, LDPE, etc. But very common feature of the extrusion process is this manufacturing line consists of extruder and a die head and sizing unit, vacuum sizing, pressure sizing, sizing sleeve, cooling trough, caterpillar, takeoff unit. These are the various parts of the machine. Extruder is very important with the die. Sizing unit is also important in order to maintain the proper size of the pipe. How the sizing is done? We have the different techniques called vacuum sizing, pressure sizing, with the sizing with the help of the sleeve. And once we produce the pipe, it will be in the hot form, should be cooled sufficiently in order to maintain the shape and to solidify for the further operation. So that is done in the cooling trough, and the caterpillar is there that will drag the produced pipe at a constant speed, and the takeoff unit is there. So these are all important parts of the pipe extruder. How the extrusion of the pipe is done? The material in the form of molten melt stage, which emerges out from the pipe die, is calibrated by using any of the above sizing methods. That depends upon the die of the pipe, that is of the required size through which it is passed and passed to the cooling trough. The extruder is a common one, which is having a screw which is placed inside the barrel, and band heaters must be there, feed hopper will be there at the end, one end, and other end there will be pipe die fitted to it with the breaker plate screen arrangement. So whole setup should be there, and when the molten material which emerges through the die, that is then sized according to our standard size, then it should be cooled, and it should be then wound, or it is been coiled. So for melting the material, that extruder portion will be there, which is having the three zones: feed zone, compression zone, and exit zone. In these three zones, material will be heated, melted, and pumped to the die, and the flow will be laminar type when it comes out of the die. And filtering arrangement is there in order to build up the back pressure, in order to prevent the foreign material or unmelted material which is will be going to pass through, that is prevented by the screen pack and the breaker plate arrangement. From the die, as soon as it comes out, it is been sized. Any of the techniques, pressure sizing, vacuum sizing, or by sleeve sizing method, we have to adjust the size of the pipe. Then immediately it is passed to the water bath. It is passed under the water. When it emerges out from this bath, it will be completely solidified. Then it is passed to the caterpillar. The dragging is done continuously at the constant speed. The same, at the synchronous speed, it is been dragged. At what speed the extrudate comes from the die, the same speed it should be dragged. So caterpillar will do that work. After that, measuring device might be there, particularly brand names, sealing operation might be there, a cutting section, cutting to be done to the required size. Then it is wound or stacked in our any place, stacking place. So there are many problems when we process, when we produce the pipes. And what are the chances of getting the defects over the product? What are their causes and the remedies suitable? Suggest we can say have a look of this. Commonly, there will be a problem called uneven thickness. The wall thickness of the pipe may not be of same. If you cut a pipe and if you observe the wall thickness, if it is correct when you measure at different points, if it is same, then we say this is the best quality product. If the thickness of the wall thickness is not uniform or same, then we call this defect as uneven thickness. What is to be done? So we have to set properly, otherwise the same problem will continue, because the extrusion is a continuous process. And the cause for defect might be die is not centered properly. When we fix the die of the particular size, so it should be cleaned well and should be set correctly. So die, if it is centered properly, there will not, this kind of problem will not be there. So die is not centered properly, that is why you get this problem. What is the remedy? We have to adjust the die, so that adjust the die, then you have to check again. So after that you can confirm whether is okay or not. Then if it is okay, not okay, then again we have to adjust and we have to see. So that way the thickness of the pipe can be maintained same throughout the circumference of the pipe. Second defect is rough surface. If the temperature is not sufficient, a low temperature is the cause. And how to overcome this problem, rough surface? So we have to increase the temperature little bit, so that this problem we can overcome. Third, there are chances of this problem that is called porosity. Porosity is because of the moisture present in the raw material. So what you have to do? So if there is a moisture, we have to pre-dry this material, so that this problem we can overcome. Avoid moisture by pre-drying. Pre-drying is nothing but drying the material before we process it. So various types of pre-drying equipments are available. Even on machine also at the feed hopper, bottom of that drying arrangement is there. There is such modified versions of machines available. Otherwise, in small machines, if this type of arrangement is not there, then we can go for say tray dryers, in which material is loaded and approximately at 60 to 70 degrees Celsius, about 20 to 30 minutes should be pre-dried. Such pre-dried material if you use for production, there will not be any porosity problem. The continuous line is another problem. This may be due to the damaged die. So when we assemble the die or dismantle the die, we have to take a lot of care. If the die is damaged, say the any projected area, that will be going to have the certain effect over the product. So even degraded material, if at all present in the die, that will cause this problem. How to overcome the continuous line defect? So we can overcome by replacing the die or the check for material degradation. Damaged die should be, again it should be repaired so that we can overcome this problem. So whenever you use a die, you have to check it properly, you have to clean it properly, then you have to fit to the pipe extrusion line. Next is one more problem called oval shape. The correct good shape pipe means it should be of circular shaped one. If the shape is oval type, so this is a defect. This is due to the sizing unit is not perfect and improper cooling. Cooling is not perfect means if it's not cooled properly, when it reaches the caterpillar, so due to the pressure applied for dragging, holding unit is there. So there it is pressed. If it is not solidified, it will attain the oval shape. Sizing is if not done, then also it will be having this kind of problem. So we have to rectify it and we have to check for cooling. If the water bath provided in the water trough, it is heated up to the higher temperature, we have to circulate the chilled water. We have to bring down the temperature so that the cooling will be done properly. And this is another problem called a depression. This is again due to the moisture present in the material. Same what we have to do as we discussed in the porosity problem, pre-drying, same pre-drying is done here also to overcome this problem. Now let us watch a video
Now let's
of
look at
pipe
the inside
production.
of an extruder to see how it works.
See here
The plastic raw material
how
in
the
this
material
hopper
is going
travels by
to
gravity to the
charge
feed
into
rotor
the barrel
and
is
drops
shown
onto the
with
rotating
the help of
spool.
a feed hopper.
The
Material
rotation of
is
the spool
charged,
conveys
that
the
will come
plastic
down,
forward through the
material will be
heated
carried
barrel.
forward and forward from this feed
As
end to
the
the exit
plastic is
end.
conveyed
Now the
forward along
screw
the
which is
screw,
placed
the
inside the
channel
barrel
depth decreases,
that takes
forcing
the
the
material
plastic through a
in
smaller
forward
area.
direction, and it will
The
be
combination of compression
say
and screw
compressed to
rotation
the higher temperature so that this material will be carried forward and the pipe is being produced. What are the profiles? We make use different profiles for different purposes. Say it is the process by which the various plastic materials are used to develop quality products. These products have a continuous cross section such as the pipe, drinking straws, and decorative molding, and roughing, and window trimming, and many other things. So profiles of different shapes are available. What are the common defects causes in film extrusion? Say discoloration will take place. That is the one problem. That is because of the overheating. Check for condition and the color feed. Reduce the temperature if this is the problem, if overheating is done. So that you have to reduce the temperature. Wearing thickness, improper die setting is the reason. and we have to adjust the die opening. Wrinkles, bubble, instability, that is the problem. And what you have to do is we have to do the alignment of the nip rollers, and the bubble which is going to jump like this, move like this, then we have to stabilize it, ensure the proper alignment. And the cable extrusion, see how the cables are produced. Cables are also produced by extrusion process. In the first step, our aim is to acquire the metal wire. Metal wires are nothing but the conductors, usually made out of the copper and aluminum material. With the American wire gauge standard we make use. The method is to pull the copper or aluminum rod through the series of synthetic diamond dies while it takes the shape of the wire. The shape is going to be gradually decreased in size and on the draw bench. And this is the processing with a lubricating and cooling system that is increased in life of die and prevents the wire from overheating. In the second step is the annealing of the wire is to be done in order to attain the better strength. During the drawing process, we apply tremendous pressure on the metal rod to form a thinner wire. Thus, a wire we get is extremely brittle and can easily be fractured if flexed. The finished wire must be flexible, so in this step we are going to soften or anneal the wire. Annealing is accomplished by heating the wire to its recrystallization temperature for a period of time. The key here is to avoid oxidation of the wire. Third step is the manufacture of the cable is twisting and stranding. As mentioned earlier, now the multiple wires often get stranded. That is because given the same cross-section area, standard wires has a better flexibility and electrical performance than the single wire. In this twisting and stranding step, two or more wires of the same gauge are twisted or stranded together using a proprietary formula to determine the twist length. Fourth step is the wire now, which is soft and flexible, is passed through an extruder where the coating of the plastic and on the other insulating material is applied. Materials are poured onto the rear part of the extruder and are pushed forward while heated into melt. Extincting Exiting the extruder, the coated wire passes through another cooling system and is cooled on reels. In this diagram, you can watch how the PIC cable is made. Now, wire coil which is placed here, which is a conductor of the wire, this is taken out and it is tested by passing through the small opening through the gauge, and it is passed to cool and say now the wire from this side it is taken, it is fed to the extruder, from it will get coated up and this is then passed and it is been reeled. So the ready gauged a particular gauge wire, copper wire is taken and it is passed through the wire extrusion die, that is wire and is a separate type of die is available, wire extrusion die it is called, so through which it is been passed and it has been coated. Cabling is another technique, that is how to make the cables. Basic component of a cable is now prepared. Now next we need to assemble the cable according to different utilities. This process is done in a cabling station for the electronic cables in daily use. We just need to wrap up one or more strands of wires together with interference preventing layer if needed into the protection jacket. In order to have a better forming degree, we often use filler to ensure the finished cable in proper shape. In this diagram, you can watch a cable. Number of wires have been placed. Here, see the fiber is placed and loose material is inside. Filling compound is placed here and say the inner sheet is there, outer sheet, this corrugated sheet, tape, inner sheet, then this is a wrapping tape and phosphoric steel wire and filling compound is placed. All this is a cut section of a cable and inside if you number of wires are visible. For power cable and other cables that need to be buried underground, there are more protective measures. Bedding or inner sheet, usually a plastic layer to keep the inner wires together and prepare the bed for steel armor. Steel armor is a very important layer which is made of the steel. It is to sustain the pressure and prevent the pest underground. Outer sheet is usually a layer made from the same material as inner sheet applied over the armor for overall mechanical, weather and chemical and electrical protection. How the plastic films are made. Plastic films are also made by extrusion process. For any extrusion process, the heart of the process is extruder. The downstream equipment varies as per the requirements of the end product. Film extrusion can be broadly classified into two types. One is a blown film, second is a cast film. What is blown film? Blown film are the cheaper type of films, plastic films. More plastics go through the blown film lines than the other extrusion lines. The process can vary in direction, up, down or horizontal and in the method of flattening the film prior to wind up. Developments in these lines relate to the extruder, dies, takeoff system, automation components. The development of high-speed extruders with the grooved feed zone and barrier screws make it possible to increase output while providing greater processing flexibility. This makes it unnecessary to change the screw, particularly in co-extrusion. Blown film dies are of different sizes we must have. Say for example 4-inch flat width, 6-inch, 8-inch, 10-inch. So different size dies we must have. These blown film dies are of circular in shape with a goal of low pressure consumption, good self-cleaning, material changes and ease of maintenance. Automation of blown film plants to reduce the film thickness tolerance involves the increased use of linear weight control system. Regarding the film direction, horizontal operation entails no overhead installation and low building height, but requires larger floor space with the probable adverse effect on gravity and uneven cooling. Here you can see a diagram of blown film extrusion. The material is pre-dried and it is taken from the silo. It is fed to the feed hopper. This is the extruder through from which it has been melted. It will be pushed out of the die and this is the die section. Next to the extruder there will be die attached to it. The material will be moving upwards in LDP production, HDP production and all. And it will be as a balloon or a bubble. It comes out of this die. Very near to the die there is a ring, air ring it is being called. Air is blown over the film or bubble shaped one, so in order to cool it, to solidify it. Then it will be collapsing frames will be there through which it should be passed so that instability or the shaking of this bubble can be avoided, and the bubble is passed through the nip rolls, and these are idler rolls through which it is taken in downward direction. These are called idler pulley. Then it is wound on bobbin. Roll of film is shown here. So starting from the material, how it is been processed, and in the form of film, here flattening of the film takes place. Air will not be going out. How the bubble is maintained? We have to here pump the air. There is a nozzle, air nozzle is there, and we have to bulge it to the required size so that the wall thickness we can control. If you want to reduce the thickness, we can pump more air so that the balloon will be going to be blown to the higher, bigger size, and the wall thickness can be controlled. And the checking of cross-checking of this wall film thickness and lay flat width all is done at this end, at the end stage. See here, this is the cut section of this extruder feed stock. From here the extruder screw is there, and the screw barrel arrangement is shown. Already we had discussed in our session 1E1, and in this case the common type of this extruder will be there. From there pipe, not like pipe die, here film die is used. The film die is of the not a straight die, it is of this shape, L shape. Molten material comes out in this direction. It is taken in upward direction and it is made to flow up in the form of bubble upwards, which leave the die here from here. And from here air is pumped so that this sticking is avoided and the wall thickness can also be controlled. In this diagram, you can see how the film is going to form. The line diagram is shown. The molten plastic material which is coming out of the breaker plate, then it is going to pass through the die. Air is pumped so that the proper say wall thickness can be maintained by adjusting the diameter or the size of this blown tube, which is taken out through the nip rollers, and then it is taken downwards and it is been wound. Here you can see the die. This is the blown film die from which the molten plastic material is emerging out, and inside also we can pump the air. From outside you can pump so that from here it comes out through the nozzles, and the bubble size can be maintained, that is shown here. This is the blown film which is on line, and it is next flattened here and then it is wound. How the flat films are made? Flat films, especially for cello tape etc., are produced by this technique. Flat films are processed through slit die, and they are cooled primarily by using the chilled rolls. Many different resins are used for flat film. Alternatively, certain plastics go directly into water tank, but that creates many technical difficulties in production. You can see over here how from the reclaim hopper the material is charged. Virgin resin is charged into, and from the extruder, different extruders have been shown. It is passed to the common slit die. From a common hopper, it is extruders are charged individually, and from there this molten material comes, and the common die it comes over here, and any width of the web can be produced. Then it is passed to the chill roll. This is the second chill roll. This is called corona treatment roll. All dust particles are all removed off. Then it is passed to the gauge, and it is then trimmed at the sides. So then it is wound here to the required size. It has been cut. This 1, 2, 3 different length. Accordingly, we can cut and we can wind. So this is the process for making the flat film. How the sheet films are produced. It is used to extrude plastic sheet or films that are too thick to be blown. Sheets are of course more thicker than the film, so we cannot produce by blown film technique or any other technique. There are two types of dies. We can make use T-shaped die or and also coat hanger type of die. The purpose of these dies is to reorient and guide the flow of polymer melt through from a single round output from the extruder to a thin flat planar flow. Sheet film. Say here from the feed hopper material comes here through the extruder screw, it is taken forward direction, heat is supplied from the outside. This is the screw drive motor. From the breaker plate, then it comes through the die, and from the die it is a certain width material, it is coming out, which is then cut, cooled first by passing the chill rolls, then it is been cut, trimmed, all this done later. Now let us discuss about multiple choice questions of this session 2. Question number 1. Discoloration of film is due to dash. Discoloration is change of color. This is due to the overheating of the material. Improper dye setting, wrinkles, improper dye setting. No, these are not the reasons. Due to the overheating, only discoloration takes place. Second question. Varying thickness of film is due to improper dye setting. If the dye is not set properly, wall thickness may be going to vary. So correct answer is improper dye setting. Wrinkles in film is due to, that is the reason, bubbles instability, not due to the overheating or not due to the improper dye setting or discoloration. Wrinkles due to bubbles which is going to form, which comes when the molten material comes out of the die, it forms as a balloon because it is been blown by pumping the air. If that is not stable, it is like a shaking type, then wrinkles are going to form. That is the reason. Question number 4. Uneven thickness in pipe is due to, this is related to the pipe production. Rough surface, porosity, dye is not centered, moisture content. So uneven thickness of the wall, that is due to the dye is not centered. Question number 5. Continuous line on pipe is due to. This is due to damaged dye, degraded material in the dye, and C is both A and B, D is moisture in material. Answer C is correct, both A and B. That means continuous line on pipe is due to damaged dye, and also there is one more reason, degraded material in the dye. Question number 6. Oval shape of pipe is caused by dash. Sizing unit not perfect, improper cooling, moisture in material, both A and B. So oval shape of the pipe is due to, caused by, sizing unit not perfect, improper cooling. Question number 7. Porosity defect in pipe is caused by dash, moisture content, damaged dye, low temperature, overheating. So porosity is due to moisture content in the material. Remedy for porosity problem is avoid moisture by pre-drying. We are just now come across why the porosity problem arises. This is due to the moisture present in the raw material. So what you have to do? Remedy is avoid moisture by pre-drying the material. Thank you.